Hello everyone, you are welcome to my YouTube channel, Messed Up Mentors. This is Python for All. In today's video, we will looking at plotting with Matplotlib. Here, we're looking at how to visualize our data and communicate insights. And plotting in Python is one powerful way to do that. There are many different Python libraries such as Bockel, Plotly, Seaborn, Alta, Folium, but the most popular of all these libraries is the Matplot library. To plot using Matplot library, you simply import matplotlib.pyplot as PLT. PyPlot is a sub package, okay, of the Matplot library. So, and we have other sub packages like CM, axis locator, and all of. But first, to do the major plot, just import matplotlib.pyplot as PLT. Then you can create a new figure and plot your data. To create a new figure, you simply use the plt.figure function because you have imported matplotlib.pyplot as PLT. So, and then to plot, you also call plt.plot and pass in your arguments. Uh, Oftentimes, primarily, you just need basically two arguments, the x-axis and the y-axis. But you can provide additional keyword arguments, okay, such as the line color, the line width, the legend, the font type, the font size, etc. Finally, you can display the plot using plt.show. You can also save the plot using plt.savefigure. All of these are functions in the PyPlot sub-package. So let's begin by showing some examples. Here we import matplotlib.pyplot as PLT, and also I need the CM package. CM simply refers to the color map. You see where we use the color maps very shortly. So I take from matplotlib import CM, which is import color map CM. Then I can now call CM to get my various color map. I've commented out import warnings and warnings dot filter warnings ignore. The reason is that when there are sometimes when you run your notebook can throw up some warnings of some features that will be deprecated, in future release or in future versions of these libraries. If you don't want to see those warnings, you can actually, ignore them. Okay. I will leave it commented, and when those warnings show up, I'll go back again and uncomment them to see how we get a nicer display or output without those warnings littering our notebooks. So here I have a data that captures Python's popularity. In here, this is Python popularity, Python language popularity. Yeah, that's what it is. Python language popularity. Yeah. It's okay. Python language popularity in year from 1991 projecting until 2025. You can get the data online, then the popularity in percentage. Okay. So running this, this is my namespace. You can make a line plot of this. First, to make a line plot, okay, which is a 2D plot, you simply remember I've imported matplotlib the pyplot as PLT. The next is to what? We can initiate by calling the figure. This is one way of doing it. You can call the figure, and here, let's see, and comment out the figure size, right? Then you plot by saying PLT dot passing what's your x-axis, the year, what's your y-axis, popularity. And then I put in further arguments. I want a blue, okay, line with asterisk, and then all the lines connected. You will see that very shortly. Then you can call plt.x label, pass in the label and the font size, the y label the y side, the y label and the font size. You can also put the font weight, okay, and then the title of the plot. Okay, it depends on you. You can put in the plt.title or remove the title. Then you show the plot. If I run this cell, what do I have? It throws up an error PLT. Yes, because I didn't run this, I don't have this in my namespace. So running this, put that in my namespace. Then I'll proceed here to run. What do we have? We have an output figure. You can see it, blue with asterisk as a line. If you don't want this blue, you can change this color to red. You can decide just to have red of asterisk and no connecting line. If you run again, this is what it gives you. So whichever output you want, you can format it to look that way. Mind you, by running this here, Python, the Matplotlib uses the default figure size to display the figure. But you can choose the size of your figure by coming here and uncommenting this. If I run again, you see the figure size increases. It takes 12 by width and 6 by height to make this plot. You can tweak it to whichever. I can make it smaller. Yeah, smaller, 3 by 4, 3 by 4, whichever size you want. 3 by 4 becomes smaller. There's a lot we can do. You can always tweak this figure size. If I have 8 by 10, figure size, run, you get me. So you can have 6 by 8, default figure size, you run. Okay? Whichever size that suits you. So I can have red and this line, and you draw, it gives you that. So you can leave it blank with no figure size. It uses the default figure size to plot. Next is I will show you how we can make a pie plot. Here is a line. First is a line plot. Next is a pie plot, a pie chart or a pie plot. To do that, we call figure, comma, axis ax equals plt dot subplots. There's what we call plt dot subplots. Okay, and then we to plot it by calling axis dot pi popularity, your x-axis, what you want. Here we don't have x and y-axis, so the pie plot gives us we plot the popularity, and the label becomes the year. Okay, and then we use this auto pct to format how the label is printed. We want it to a decimal point, floating point. Okay, percentage symbol 1.1, percentage symbol, percentage symbol, and then we'll put in a title and show the plot. If you run this, what do we have? We have this pie plot. We can see it now. We have the pie plot. The color is automatically selected. Okay. We can also decide to do a bar plot. Okay, to do a bar plot, you can see here, I'm not using the subplot module. You can use this. I'm trying to show you the different ways of plotting in Matplotlib. You can use the axis, okay, call the axis and subplot, or you can use the PLT directly. Okay, if we do that here, we have PLT.bar, passing the year, popularity, and I want the color to be green. Then the X label, the Y label, the title, and I show the plot. If I run this, I have, you can see the popularity of Python when it started in 1990, very small, and rising almost now in 2025 about 20%. Now we can repeat the same pie plot using the PLT. Okay, we have imported matplot as PLT. So here we have PLT, we pass in popularity, labels is here, colors, and I pass in the respective colors. I have how many? 8. 1, 2, 3, 4, 5, 6, 7, 8. So I pass in 8 colors. You can randomly generate these colors. I will show that in my subsequent videos, how you can automate this without having to hard code this. Okay, you can randomly generate this hexadecimal code that represent each of these colors, and each time you run randomly, the colors are varied. We'll see that very short in our subsequent videos. So if you run this cell, what do we have? We have the same colors assigned, and then we have the same pie chart or pie plot. Okay, so here also we can do further customization using the subplots. Okay, axis subplot. There we put define the distance between this label and the pie chart. We define the label distance, the pack distance, and we can do all of this customization. If you run this, you see it come. The values are printed closer as compared to this. So we have, you see, the years placed inside the pie chart and the percentage put in outside. Unlike here, we don't have we just have the year and the percentage is not labeled there because we actually did not pass that into this place. We just plotted. Okay. But here we have passed in this auto pack, and then it gives us that just like we did here as well. So next, we can also decide to explode a section of this pie chart. So we create a tuple and then put in the value for the explosion, how much explosion we want, okay, in fraction, okay. So I want to explode the first data point. So and then I call the same pipe plot, and this time I'll pass in the explode equals explode. Okay, this if you run this code, what do we have? It explodes. Can you see the first data point, 1995? If I want to explode the last, all I need to do is to come here and or the last second to the last, I want to explode by this. If I rerun this code, it explodes that data. It's like cutting it off. I want to, show this, and so this is how much you can tweak. Remember, I also created shadow. I want them to show shadow. You can see it showing here. At what angle do I want to explode it? The start angle is 30. You can change the start angle to 90. If you run this code, you can see the start angle is changed. You can extend the start angle to 60. If you also run, what will happen? You see the start angle. It's just like rotating um, the angle at which the pie chart is the explosion is shown. So having said this, we'll proceed to the next plot. Here we'll be looking at how to do 3D plots. First, I need the NumPy library, so I import np.numpy as np because I want to generate the data that I will use for plotting. So to do that, we always in 3D plots we do axis. Call the figure. Remember to plot, you need to call plt.figure, but we assign that to axis and use another function, add subplots, and specify the projection to be 3D. I love using the double quotation mark, 3D. The next is for us to make our grid for plotting. In three-dimensional plot, we have the X, the Y, and the Z. So to do that, I will use what is another function in NumPy known as mesh grid. Okay, so if I have separate values of x, y, z, I need to create a mesh of it to be able to plot in the space. So I will have np.arange. My value ranges from minus 0.5 to 1 with an interval of 0.15 for x, for y same, and for z interval of zero point 0.1. But you can see within the same range 0.5 minus 0.5 to 1, 0 minus 1 minus 0.5 to 1. Then the next thing here is that I would make the data. Here I want to do a quiver plot. Those in fluid mechanics and experimental will understand what my quiver plot. I want to plot the arrows, show the displacement of this how will I put it? These points in space, how they move. So here you can get this from this online. Got it from textbook. So here I make a velocity u vector v, which is np dot sine x times np dot pi. In other words, pi x. Here I have pi y. Here I have pi z. Then v is minus cos pi x, pi y, pi z. W is now np dot sqrt square root of 2 divided by 3 multiplied by np dot cos pi x, pi y, pi z. And all of these is multiplied together. We can see it. That's why we have this larger bracket. So having done that, we have created our data. I can then plot, call the quiver plot, and pass in the position x, y, z, And then the directions of the arrows are your U, V, and W. What length? I want the length to be a fraction of 10%, 0.1. Normalize true, okay, normalize the values, okay. And then what color? Red. And then I can show the quiver plot. If we run this, what do we have? You can see this is telling us some warnings that in future, some, you know, the way this function will appear, okay, some of there be some changes. That's a matplotlib deprecation warning. So if I don't want to see this warning, right? Let's continue. So it shows us the quiver plot in red. You can customize this to your own taste. If I don't want red, I want to see it as green. You do the same thing to the color. You can change this arrow strength to zero point 0.2. And then when you run again, you see you have a longer arrow showing the direction of flow or movement of the point in space. Next, I'll also do another 3D plot, but in this case, I want to do a surface plot, not a quiver plot. So I want to show a quiver plot, which I've shown, a surface plot, and a contour plot. So also the same thing called assigned to axis, plt.figure, add subplot, projection should be 3D. Then make your data using np.arange, okay, numpy.arange. The reason why we use arange is that we don't use the normal Python range function. That the range function do not accept floats, it only accepts integers. So, but numpy.arange is another hack that allows us to, you know, find the range of numbers for floating points. So to do that, we create a mesh grid of x and y. And then we compute z using this function, which is like the square root of the sum of the squares of x and y, and call a sign on it. In other words, we have sine square root of x squared plus y squared. So our assign a surface plot to ax dot plot surface x, y, z. C map, I want what color should I, use in plotting that surface. This is where I call the cm.co1. Remember, we imported from Matplotlib cm color map here. Here. So all we need to do is to come now and choose which color map. First, I choose cool one. What is the width? 0, line width 0, enter, last, true. Don't bother too much about this. You can read the documentation to get further description, but we just pass that in. Just you can ignore it and just stop here. You will still get same result. Then we set the z limit. Each time you use the axis, you access the axis with figure, we always use dot set z limit dot set x label dot set y label dot. I will show you that very shortly. So the next we call figure. Remember the figure, and then color bar, passing soft, shrink, aspect. Okay, I don't know how to explain this when I display the figure. So if you run this, what do we have? It gives us this figure. Now, the color bar is telling us, giving us the limit, the range of this color. That's what they have as color bar. So this color bar here, this other function is to shrink to reduce the size of the color bar. The aspect is the ratio of the length and the width, and the pad is the distance from this z-axis. You can notice that the x-axis, y, and z has no label. So we can put in that label here. We call ax.set. Here we have X label. What should it be? It should be X. AX.set. Here, Y label. It should be labeled as Y. Right? And then lastly, we have AX.set label. We have Z label. And there should be Z. If I put in this here and run this again, what do I have? I have the labels X, Y, and Z. You can as well also pass in the units. Whatsoever you pass in here, you get it, printed out to the plot. So next here, we want to see how we can do multiple 3D plots. If you have more than one 3D plot, how do we do that? Then we need to import some default data sets from mpl underscore toolkits dot matplots 3D dot axis 3D. This itself is a sub package in Matplotlib. So from this, we can import all of this. It's default in Python. When you install Matplotlib, you can easily access this. So here now we define figure to be plt.figure. We pass in the figure size and call plt.fig aspects. In other words, I want to size in two figures in a single plot. So what aspect? 50% each for the full canvas of 100%, have sized it as 50%. So we do the first plot by this fig is calling the full figure canvas, okay, the full figure canvas, and then part of the canvas, half of the canvas to take the first plot, another half the second plot. So I have ax equals fig dot add subplot. Okay, now in this case we have to pass in this subplot. Okay, how do you want to position the figure? I want two figures. Okay, which is, remember, 1 by 2. So number of rows, 1. How many columns? 2 columns. That's what this first two is representing. If I want 4 figures, I can decide how I want them. If I want them as 2 by 2, that's 4. So the first one will occupy 1, 2, 1, 1, 2, 2, 1, 2, 3, 1, 2, 4. If I want 6, same. Well, here I want 2. So I want 1, 2, 1, 1, 2, 2. So 1 row, 2 column. That's why you have this there, 1, 2, 1. Projection 3D. I want the projection to be 3D. Then I'll generate my data, np.arange, y data, create a mesh grid, look for the sign. I'm simply using exactly this previous uh, data I generated here, and I'll call a surface plot, cool warm. I want to change this to jet, the CMAP to jet, anti-alas true. Then set the while z limit between -1 and 1. Okay, then call the color bar aspect ratio part. Then create a second plot, subplot, okay, which is the second plot. Here I also have its own axis, figure dot subplot. Remember, because you have created this one figure, you the axis will be calling that figure and adding a plot to it. Call the figure, add a subplot to it. This time around, 1, 2, 2. Projection is what? Is 3D. And then here my XYZ would get the data, okay, from get 5% of the data from this test data that have been imported by default. Okay, in every pattern installation you will have it there. Then this time around I want to plot wireframe. Okay, in other words, I want to do a surface plot using a wireframe plot. Okay, we have XYZ PLT show. If we run this, what do we have? Never mind what is being displayed. These are those warning errors. You see, it gives us this first plot and the second plot. Okay, 1 to 1. If I don't want as 1 to 1, I can have it as put it at 2, 2, 1, 2, 1, 1. Okay, this is no 2, yes, 2, 1, 1. This becomes 2, 2, 1, 2. In other words, I want it as a single column and 2 rows. If we run likewise, what do we have? Returns this. You can see it was not well positioned because of this color bar that I've used here. So I will undo this. So I'll come back here. Where am I here? I have it as 1, 2, 2, 1, 2, 1. So run again. Now to remove these warnings, the application warning, tell us what happens in later feature of Matplotlib. This happens often with Jupyter Notebook. I will just go up and up, and here I will remove the warnings. Import warning, okay, import warning, and then I will filter the warning and ask him to ignore this warning. Run this, I have it in my namespace. I can come down here and rerun my first 3D plot. This I have. What do we have? It prints that with no warning. Run the next one. It prints that with no warning. And then this which you have just run lately pulls that out with no warning. Okay. The last plot which I'm going to show you, 3D plots, we'll look at today before we end this video will be plotting, doing a 3D plot with polar coordinates. Here we call the plt.figure, right? And I will add figure, add subplot. The reason why I don't have defined the number, I just want a single figure. There's no need to create a canvas of 1, 2, 1. It's just a single figure. When you have more than one figure, then you have to create the configuration of how you want the figure to be placed in the whole canvas. So that's why this is there's no argument passed in here. So I'll have R here. I create a linearly spaced vector between 0, 1.25, 50 of it. P, create a linearly spaced vector between 0 and 2 times np dot pi, 50 linearly spaced vector. Then I have define, make a mesh grid of this. Excuse me, make a mesh grid of this. And then compute my Z, and then proceed further to express the mesh in Cartesian coordinates by using this expression x and y. Okay, and then I can plot, do a surface plot, ax dot plot surface x y z, and here I use a jet cmap. Also, you can decide not to import cm from cmap. You can call cm using plt. So you have plt.cm dot, and then you pass in the color map. There are just not a single way of doing this thing, more than a single way of doing it. So you can explore this. I'm trying to show you the different ways which you can do these things. So we set the z limit, set the here now we're showing phi of r, of real component, of imaginary component, and then setting as v of phi of x. So having done this, then we show the plot. So if we run this, it displays exactly this polar plot using this jet C map. If you have any question, please leave it in the comment section. If there's any other content or any areas you want me to shed more light, or want me to give more detailed explanation, also leave it in the comment section. Like this video, share this video, and if you are watching this video and have not subscribed to my YouTube channel, please do well to subscribe to my YouTube channel. I will see you in my next video. Bye.